Welcome to Unit 5A, Quadratic Functions. In this lesson we're going to be focusing on skill number 31 and 32. 31. I can define, identify, and graph quadratic functions. And skill 32. I can transform quadratic functions and identify transformations from graphs and equations. This is your notes for page 05-02, Properties of Quadratic Functions, skill number 31. I can identify, define, and graph quadratic functions. We've seen the linear parent function shows a constant ratio between the first order differences. A quadratic parent function, however, does not have a constant ratio. You can see in the table presented the pattern is different. We will see in a future page how this pattern varies in relationship to the quadratic parent function. At the bottom of page 05-02, I have listed several examples of quadratic functions, as well as a few examples of functions which are not quadratic. In brief summary, a quadratic function is a polynomial of second degree, meaning it should have x squared as a term and x possibly and a constant. Do not be confused when you see a square root. This is not an example of a quadratic function, even if it has the x squared. Here's page 05-03. I've created a table of a quadratic parent function as well as the graph of the quadratic parent function. As you can see in the table of the quadratic parent function, the first order differences follows a pattern of odd numbers, 1, 3, 5, 7, 9, and the second order differences is actually always going up by 2. This pattern only exists if we are moving up 1 with every step. And that's just the parent function. When we go to graph the quadratic parent function, the best way that I've found to graph it is first we locate the vertex, and then from there we follow a pattern of out 1, up 1, out 1, up 3, out 1, up 5, out 1, up 7, out 1, up 9, etc., etc. And we're going to reflect that because it's always a perfect mirror. Out 1, up 1, out 1, up 3, out 1, up 5, out 1, up 7, etc. When it comes to plotting a quadratic function in my class, I would like you to plot the vertex and then plot all points that fit on the given graph. Take pride in your graphs. This is page 05-04, skill number 32. I can transform quadratic functions and identify transformations from graphs and equations. As you can see, this page consists of two trifolds, the first being Vertex Form and the second being Standard Form. If we go to the next screen, when you open up your Standard Form, this is Vertex Form, Vertex. On the first flap you will have the basic formula for vertex, and then on the inside we have key features of the vertex and an example of how that works. I've actually provided you with 2 examples. When we go to the standard form, what we have here is the standard form of a quadratic equation. F of x equals ax squared plus bx plus c. On the inside of the trifold we have all of the same key features listed, and then one example of how that works. Most people are able to get the axis of symmetry and the y-intercept and the opens upwards. The vertex is a little bit more challenging because it requires some calculation, but once you get the hang of it, it should not be too hard. Page 05-05. This is an example of how we can use the vertex form of a quadratic equation to discuss what the shape of the parabola looks like. In the vertex form, A, the number in front, would define the vertical stretch or compression. H tells us our horizontal shift, and K tells us our vertical shift. So you can see in example 1, we have an A value of 3, which tells us that we have vertically stretched the graph by 3. So instead of going out 1, up 1, out 1, up 3, out 1, up 5, we would instead do out 1, up 3 times 1, out 1, up 3 times 3, out 1, up 3 times 5, out 1, up 3 times 7, etc. The H in this problem is -4. -4, which means we are moving to the left 4 units. I noticed that it says x plus 4, but remember, x plus 4 is equal to x minus -4. That means our h value is -4. Finally, our k value is +5, so that means we're going to move up 5 units. One last piece, the a value is the a value is positive, so there is no reflection. If it was negative, it would be a reflection. I've shown the reflection in example 2. So the negative tells us to reflect. The 1/2 tells us to vertically compress by 1/2. The positive 21 means move left 21 units. And the -6 tells us to move down 6 units. On the next screen, I should have an example of this with a graph. All right, page 05-06, example 3. Write a rule for a quadratic function that has been reflected over the x-axis, vertically stretched by a factor of 3, shifted right 4 units and down 7 units. So in this process, what I've done is each function is the next step of how we are transforming the parent function. So in the first one, we have the parent function. In this one, we are reflecting over the x-axis, and that's by using the negative right there. Then we wish to stretch it by a factor of 3. So our stretch is the number 3, a stretch of a factor of 3. So now we have the reflection is the negative, and then the stretch is the 3. From that, we wish to shift our graph horizontally to the right 4 units. To the right 4 units is this -4. So x becomes x minus 4, and that means shift right 4 units. And then the last piece is to shift down 7 units. So what we're going to do is we're going to add -7, or more simply just subtract 7. So what we've done is we've taken a graph which looked to be a parabola like this, and we reflected the parabola by using this -x. So now we've got a parabola which looks something like that. We stretched it so it gets a little bit longer and skinnier. Then we shift it right 4 units, and then finally we shift it down 7 units. So this is a graph that has undergone all of these transformations. When it comes to testing the skills number 31 and 32, there are several key things we should be able to do. For skill number 31, we should be able to write out a table of the quadratic function and graph a quadratic function, and we should be able to identify, and that comes from page number 05-02. Finally, for skill number 32, we should be able to recognize the vertex form and the standard form, vertex form and standard form. And we should be able to identify transformations. So if I give you an equation, you should be able to tell me in words the transformations, left 7, down 5, vertical stretch 2. Or I can do the reverse and give you words and have you write the function rule given the words. Alright, this concludes the note-taking lesson on skill number 31 and 32. Thank you.